Okay, so taking a look at this one, it has variables with the x and the y, and it also has the numbers inside of the radical sign. So what happens if you have both? So we're just going to break this down, and I put into my calculator 40 divided by x, and then I hit second graph, so it took me to my table of values. And I have 1 and 40, 2 and 20, 4 and 10, 5 and 8, 8 and 5, and 10 and 4. And the one that I'm going to pick is 10 and 4, because I know that 4 is a perfect square. So I know that 2 times 2 will give me 4, so I can go ahead and say 2 is going to be on the outside. It got to come out of the house. And my stylus is doing weird things. Okay, so that one I've dealt with. And now I can still break this down even further into 5 and 2. Those are also prime. So I'm going to put those inside of the house because they didn't pair up with anything. And I'm going to multiply the 5 and the 2 to give me 10. Next, I'm going to look at my variables, my letters. Where here I have x to the 4th, so I know that that means that, I'll show it to you right now, but I know that these paired up and came out of the house, and those paired up and came out of the house. So that would be x squared. And they all got married and paired up. But the y's, I know I have y squared, and this one, there's one leftover y that didn't get married. So that stays inside of the house. So looking at this one, 60, again, I'm going to go to my calculator just because it's the easiest way to find, and just do 60 divided by x, and then second graph. So taking a look at my choices, I have 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. So I noticed that I had a 4 in there, 4 and 15. So I'm going to use that one because I know that 4 is a perfect square. So those got married and came out of the house as a single 2. I can break this down even further if you want to see that. And you see that they got married and got to come out of the house. And 15, I can break this down in 5 and 3, but I don't have any matches because 5 and 3 are both prime. So those would need to stay inside of the house, and they get multiplied and turned into 15. Let's look at our variables now. I have 5 x's, so 2 of them can pair up. And then it's going to leave this one leftover guy inside of the house. And looking at my y's, all of my y's can pair up, and they would come out as pairs, so I would take half, so y to the 3rd. Let's take a look at 54. So go to my calculator. Y is equal 54 divided by x, second graph. And I have 1 and 54, 2 and 27, 3 and 18, 6 and 9. I like 6 and 9 because I know that 9 is a perfect square, and it can come out of the house as a single 3. So that's going to come outside of the house. And 6, what makes up 6? I can say 3 and 2, but they're both prime. So therefore I know that they would just get multiplied and they stay inside of the house. So the 6 is going to stay on the inside of the house. Now looking at my variables, my A's, they both paired up. So they get to come out of the house. They got married. And my B's, they got married because there's 2 of them, and they get to come out of the house. And there's no variables left inside of the radicand on that one. All right, so go to my calculator. 72 divided by x, second graph. I have 1 and 72, 2 and 36. I like 2 and 36. Because I know that that's a perfect square, and they're going to come out as a pair of 6s. So my 6 gets to come outside of the house. The 2 has to stay in because it didn't find a roommate and didn't get married. It's got to stay in its parents' basement. So looking at x to the 3, I know 2 of those are going to pair up to come out as 1, and there's going to be a leftover one for the x. And my y's, all of them paired up. So I got 2 pairs of y's. And my z, I should have given myself a little bit more room, but I can see that if I have 5 z's, I have one that pairs up, and then I have a leftover z. So I'm going to say z squared because they came out of the house as 1, and then that leftover z will stay inside the house.